Hi, this is Anzar Saismani and I'm going to explain you what is the difference between a star and delta connection and in which situation you will use the star and delta connection. Here I am putting the terminal box cover near the terminal box, and here you can see I am using the star connection here, and the right side in the terminal box cover, that is star connection, and the left side in the terminal box cover, that is the delta connection. And here we are using 6 terminals, U1 V1 W1 and the above 3 U2 V2 W2, and I'm going to explain in a theoretical way. First box we are using here, there are 6 terminals, U1 V1 W1 or U2 V2 W2 above side, and here the second box also there are 6 terminals, you can see here, and the first box we are connected horizontally at the above 3 terminals. This is called the star connection. We are using the 3 phase R, Y and B in the star connection, and also in the delta connection we are using R, Y and B, and it is connected vertically in the second box, you can see, and also the images are showing on the left side in the video, see. And I will explain you what is the difference between a star and delta connection and how you will use star and delta connection. Okay, here 3-phase motor, and first winding, see here, first winding, there are 2 points. First one is the start point, another is the end point. Here there are 3 phase R, Y and B. R, this is the first winding, there are 2 points. First is the start point, another is the end point. It means here there are 2, okay, and there are 2 points. And also the Y, the start point and the end point, and B also here. See here the 3 windings, 1, 2 and 3, and star, see this is the first winding, there are 2 points, 1 and 2, and here also U, V and W. You can use this terminal terms, and or you can use the RYB. See here it is connected each other, you can say U2 V2 and W2 are connected each other in the star connection. See here in the delta connection we are using also the 3 winding, this is called R, Y and B, see here. And the third box here, you can see third box, there are 3 phase, first and the second, here is your point in the first winding, second winding here, this is called the Y, and the second terminal is here star, and the end point you can say like that. Here the B, start point and the end point, this is here, you can see in the third box very clearly. And we are using here the 3 line also, R, Y and B. See here, this is R, here R directly is Y, this is Y, and B, you can see here the B also, and the B is connected, see very clearly, B is connected with the R. First point of the B is here and the next point is here R. We can mention here B, R. It means the one winding, there are 2 phase B and R. R connected with Y, see, yeah, Y, I is connected with Y, and Y is connected with V, you can see here. Now it is okay. In the delta connection, you can see there are 2 phase R and Y in the one winding, Y and B in the second, and the B and R in the third, you can see. And it means there are 2 phase 220 220, it is 440 volt. In the star connection we are using 220 volt, and neutral U2 V2 and W2, the third terminals are connected each other, that is neutral. Here there is no current, but you cannot touch by your hand, you can use your tester. Here there is no current, this is the neutral point in the star connection, and every wiring has a single phase 220 volt. And here we are going to explain how it is produce the magnetic field in the stator. Okay, and the second thing here, we are going to make the stator. See, this is the stator, you can see the image here. This is the stator. If it is in delta connection, the voltage is more, magnetic current is more, the magnetic field generate very high. Okay, here see, if you will use the load, if you will apply the load on these areas, because the magnetic field is high, at that time it will rotate the rotor here, and you can use this energy here. Suppose here, if the load is less, at that time if we use the delta connection, efficiency will be going down. If the load is more, if we will use the delta connection, the efficiency will be more. For example, here we are using the 5 kilowatt motor, and the capacity of this 50 to 70% efficiency. If it means the load is more, between 50 to 70%. If it is 20 to 25% capacity, and the efficiency we are using here, at that time I will see what is the difference. First I have to calculate the ampere by using this method. Suppose here the motor is 5 kilowatt, and we have a short method. 5 kilowatt is multiply by 1.7 directly. This is the shortcut method. It will come directly. See here, it is valid only for 415 volt and 3 phase. This is the shortcut method. You can directly 5 into 1.7, it will become 8. In a star connection, one end of all the 3 wires are connected to a common point in the shape of Y, such that all the 3 ends of the 3 wires form the 3 phases and the common point form the neutral. Star connection is preferred for the long distance power transmission because it is having the neutral point. And in the star connection, the line voltage is under root 3 times of the phase voltage, and the line voltage is the 2 voltage between the 2 phases in the 3-phase circuit, and the phase voltage is the voltage between the 1 phase to the neutral line, and the current is the same for the both line and the phase. And delta connection, every wire is connected to the 2 adjacent wires in the form of a triangle, and all 3 common points of the connection form the 3 phases. Normally the delta connection is preferred for the short distance due to the problem of unbalanced current in the circuit. In the delta connection, the line voltage is the same as that of the phase voltage, and the line current is under root 3 times of the phase current.